This is CPM Precalculus Chapter 2, Number 12. Salvador prefers to evaluate 81 to the 3/4 power in a different way. So he knows that 3 to the 4th power, 3 times 3 times 3 times 3, 3 times 3 times 3 times 3 is equal to 81. So he substitutes and uses the power law for exponents. So he says 81 to the 3/4 is equal to 3 to the 4th, right? Because 81 is 3 to the 4th. On the inside there, we can put it in parentheses, to the 3/4. And then he knows that from there, when he has 3/4 to the 3/4, it becomes 4 times 3/4. And 4 is over 1, so the 4's cancel out, and he's left with 3 to the 3rd power. Okay, and 3 to the 3rd power is just 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So this is how Salvador prefers to evaluate 81 to the 3/4 power. So use Salvador's technique to evaluate each of these. So part A, we're given 81 to the negative 3/4 power. So first of all, we can go ahead and use his technique, right? We know 81 is the same as it was here, 3 to the 4th power. Okay, so that's substituting 81, right? These are the same. And we still have the power 3 to the 4th on the outside. Okay, now again, when we have a power to another power, this means to multiply the powers together. 4 times negative 3 over 4. And we know this 4 is over 1. So the 4 is going to cancel out. You're going to get 3 to the negative 3 power. Okay, since it's negative, and this whole thing is over 1, right? All of these are over 1, right? Everything's over 1. We can make this positive by putting it into the denominator. So this becomes 1 over 3 to the positive 3 power. And we know to the 3 power means 3 times 3 times 3, 3 times, and that's equal to 1 over 27. Okay? So that's part A. Part B, we're asked now to evaluate 27 to the 2/3 power. Well, what's another way we could evaluate this? Well, Salvador's way was to kind of break up the base, right, into something else. So what is 27? So let's go ahead and think about that first. 27, we know we can divide 27 is going to be 3 times 9, right? 3 times 9 is 27. Well, 9 is equal to 3 times 3. So 27 then is equal to 3 times 3 times 3. Or that's 3 cubed. Okay? So this, again, is our background knowledge to help us say 27 to the 2/3 power is equal to 3 cubed, right? Because 27 is the same as 3 cubed to the 2/3 power. And now we can go ahead and we know this is going to be multiply these powers together. So it's going to be 3 times 2/3, right? 3 is over 1. So these 3's cancel out and we're left with 3 squared because 2 over 1 is 2. And 3 squared is 9. Okay, so this is B. B is 9. Okay, part C is asking us 125 over 64 to the 2/3 power. Okay, so first of all, let's go ahead and see, well, what is 125 equal to? Well, 125, this is the background work. Well, if we divide 125 by 5, well, 125 divided by 5, well, let me pull out my calculator. Okay, let me just click it on 125 divided by 5. So that's equal to 5 times 25, right? 125, you could say 5 times 25. And I know 25 is just 5 times 5. Therefore, 125 is equal to 5 times 5 times 5, all three of these, okay, or 5 cubed. And how about 64? Well, 64, what can I divide by 64? I can divide it in a few different ways, but I want it to be 3, right? Because I'm going to have something over something, I want it to be the same power. So if I divide 64 by, let's try 4, okay, that's going to be 4 times 16, and 16 I know is 4 times 4. So 64 is 4 times 4 times 4, or 4 cubed, okay? I know that I can keep doing this more, right? Because 2 times 2 is 4, and 2 times 2 is 4, and 2 times 2 is 4. That's going to be 1, 2, 3, 4, 5, 6, or it's going to be 2 to the 6. But like I said, I want to use it in the power of 3 to match with the numerator is going to be now 5 to the power of 3, right? And the denominator is going to be 4 to the power of 3. Okay? So this is how I'm going to start. If I had to the power of 6, they wouldn't match. And my goal is to match them because now, let's put away the calculator. Now that they match, I can go ahead, and this is my work down here. Let's continue over here. I can say that's equal to, well, these are both bases are different, but the powers are the same. So I can say that it's equal to 5 over 4 to the 1 power of 3. So I could combine these and to say that it's 5/4 to the cubed, right? Because going backwards, I would just distribute it to both of them. We get back here. And again, oops, this should be 3. And this is on the outside is 2 over 3, right? Okay, now I can go ahead and use the property of exponents to say 5 over 4 cubed is just, n to the 2/3 power is going to be cubed times 2/3, right? And again, this is over 1, so these can cancel out, and that's equal to 5 over 4, and 2 over 1 is just 2, okay? Now backtracking, I can now distribute the exponent to the numerator and the denominator, so it's 5 squared over 4 squared, and 5 squared is 25, and 4 squared is 16. So I use this method now to do this 125 divided by 64 to the 2/3 power. Oops, and I said 5 squared is 24, but I meant 25. Thank you if you caught that. Good job. Okay, so it's 25 over 16. Finally, let's move on to part D. Part D is giving us 1/9 to the power of negative 1 over 2. And there's a hint. The hint is, express 1/9 as a power of 3. Express 1 over 9 as a power of 3. Okay, so let's go ahead and do that first. So what does that mean? So 1 over 9, well, I know that's equal to 1 over, so 9 is equal to 3 squared, right? So this is kind of a power of 3, but I can just make this as a single number by moving it into the numerator, right? And if I move it into the numerator, I have to do what to the exponent? I have to make it negative. So this is 3 over 1, 3 to the negative 2 over 1, or 3 to the power of negative 2. Okay, so that's the background work, right? And so I can say this is equal to now 1 over 9th is just 3 to the negative 2 power, so 3 to the negative 2 power, to the negative 1 over 2 power, the negative half. And now I can say again that this is the same as 3 to the power of negative 2, and we're going to multiply these exponents. Okay, this is over 1, so this cancels out, the negative cancels out, and I'm just left with 3 to the 1, which is equal to 3. Alright, so this hint helped me out a lot. Alright, this ends CPM Precalculus Chapter 2, number 12.